Okay, so let's do a quick example. The example is find the equation of the normal to the function y equals e to the power of x minus 2, and the point of contact is x equals 3. So they're giving you the x coordinate of the point of contact. Okay, so again, you need first a point. We're going to find the point first, I guess. So when x is 3, we can find the y coordinate that lies on the curve by simply plugging in x equals 3 into this function here. So if we do that, we get e to the power of, instead of x minus 2, we're going to get 3 minus 2. 3 minus 2 is just 1. And so the y coordinate is just e. So we can say the 3 comma e is the point of contact. And I'll mark it in on our graph here. Oops. Okay, now what we want is the slope of the normal. Before we find the slope of the normal, it might be easier to first find the slope of the tangent and then take the negative reciprocal of the slope of the tangent. So let me draw in the tangent first so we can see it. So here's what the tangent looks like, something like that. The normal is going to be perpendicular to the tangent. So something like that. So that'll be our normal. Before we find the normal, let's just find the slope of the tangent. To find the slope of the tangent, what we're going to need to do is first find the slope of the curve. The slope of the curve, or the function that describes the slope of the curve, is just the derivative. So first we need to find the derivative. So I'm going to do dy by dx. The derivative of e to the power of x minus e to the power of x minus 2 is going to be e to the power of x minus 2 multiplied by the derivative of the inside function. The derivative of the inside function, which is a line with a slope of 1, is just going to be 1. And so what we're left with is this being the derivative. And what we're going to do next is evaluate the derivative at a particular point. For us, that's going to be x equals 3. So when x is equal to 3, we need to find the derivative value. The derivative value when x is going to be 3, I'm going to move this down a little bit. It's going to be e to the power of, so if we input it, we actually get the same thing as the y values earlier. So the function and the derivative are actually identical here. So when we plug in 3 into here, we get e to the power of 3 minus 2, which is just e. So now what e represents is the slope of the tangent to x equals 3. Okay. Now that's not what we want. The question says find the equation of the normal. And so because of that, we're going to need to find the slope of the normal. So the slope of the normal will be equal to, we just take the slope of the tangent, which is e. We find a slope that when you multiply by e, you get negative 1. And so that slope is going to be negative 1 over e. By the way, if you're looking for a shortcut, if you don't want to write slope of the normal over and over again or slope of the tangent over and over again, what you can do is shorthand that. Typically, m, which stands for slope or gradient, with a little subscript n is acceptable. So in MathHL, you can use this notation to represent the slope of the normal. And similarly, you can represent the slope of the tangent with an m and a subscript capital T. Okay, so we have a point. So let's write this down again. The point was 3 comma e, and now we have a slope. We know that the slope of the normal is negative 1 over e. So we can write the equation of the normal. It's going to be y minus the fixed y coordinate equals negative 1 divided by e, which is our slope, times x minus the fixed x coordinate. And that's it. You can leave it in this form, and that is okay. If the question asks for it to be put into slope-intercept form or standard form, then you have to convert it over. Otherwise, it's okay in MathHL to just simply leave things in point-slope form. You'll receive the full marks, so long as they don't place a condition on which form the line has to be in. Okay, so that was a little bit long. Hopefully, you guys learned a little bit about how to describe the equations of tangents and normals. That was the goal today. And I hope you were taking notes as you were going along, and that you have these in your notebook for reference later when you need to study. The next thing we're going to do during our synchronous time is I'll give you a worksheet to help you practice the concepts of tangents and normals. And I hope you guys have a good rest of this day. Stay safe.